Okay, so for question 16, they ask us, they say a line tangent to the graph at the point 1, 7 passes through the point negative 2, 2. Then f prime of 1 is equal to what?
You have to remember that when we talk about f prime of x is always equal to the slope of the line tangent to the curve. And since we know a point on the curve and we know that the line tangent to the curve passes through a point, we can come up with the equation for the curve. Y minus y1 is equal to m times x minus x1, the equation for the line tangent, I should say. And when we do that, actually, we don't even have to do that. We have the 2 points, so all we have to do is really find out what the slope of these 2 points are going to be. So if I want y2 minus y1 over x2 minus x1, I'm going to get, let's say, negative 2 minus 7 over negative 2 minus 1. We're going to get negative 9 over a negative 3, which is a positive 3. And if this is the slope, then we need to know that f prime of 1. So here it is. If a line tangents to the graph at the point, here is going to be the x equals 1. So at that point, the slope is going to be 3. So f prime of 1 is going to equal 3, which is choice C. All right, we move to the next one. Question 17. If I can get this in here. There we go. It says, let f be the function given by f of x equals 2x times e to the x. The graph of f is concave down when, and we have to remember when we talk about concave down, we're talking about the second derivative. So we're talking about f double prime of x. And when we're talking about concave down, we know it's less than 0. So we want it to be negative. So we start by finding the first derivative. Well, the first derivative, we're going to have to go through and apply the product rule. The first is 2x, so the derivative of that is 2, times the second, plus the first, which is 2x, times the derivative of the second, which is just e to the x. Okay? So that's it. That's the first derivative. Now we got to go back and find the second derivative. If we're looking for the second derivative, we're looking for the derivative of this, which is simply going to be the derivative of e to the x is e to the x, so we got that, plus. Now the derivative of this, just understand that this is exactly what this is. So when we take the derivative of this piece, it's going to be all of this again. So we're going to get 2e to the x plus 2x e to the x. And we look to simplify that because if we have 2e to the x and another 2e to the x, we're going to have 4e to the x plus 2x e to the x. Okay, and we try to factor out what we can here because the important part here is to find out where the 0 is. So if I factor this out, I'm going to factor out a 2e to the x. That's common to both, and I get 2 plus x, right? 2e to the x, yep, 2 plus x equals 0. Well, remember, 2 times e to the x will never equal 0, so this can never equal 0. So the focus of my problem now is just going to be 2 plus x equals 0, so this is going to happen at x equals a negative 2. All right, and we're going to take our graph because we have to figure out where the overall piece is going to be negative, so there's f double prime. Here's our negative 2. Here's 2 plus x, negative before and positive after. And remember, here we have 2e to the x, which is another factor. E is a positive number, and we raise that any number, we're going to get a positive number, and we multiply that by a positive number. This is positive throughout. So this is going to be negative, and that's going to be positive. So the graph is going to be concave down when x is going to be less than a negative 2, and that's choice A. Okay, number 18. Number 18 says the derivative of g prime of a function g is continuous, has exactly 2 zeros. Selected values of g are in the table above. The domain of g is a set of all real numbers. Then g is decreasing on which of the following intervals. So remember, g, we're trying to learn something about g, and we're given values for g prime. And we're supposed to know that if g prime of x is greater than 0, we're increasing. And when g prime of x is less than 0, we're decreasing. And they're saying then G is decreasing. So we're looking for, if I want to know where G is decreasing, we're looking for where G prime of X is less than 0. So I'm looking for where G prime of X basically is going to be negative. And that's here over those pieces. That's where it's negative. So we're talking about in this interval right here. And when you look at that, that's going to be between -2 and 2. And again, since we're talking about the first derivative, we're going to include the endpoints. So we're going to include 2 and include -2, and that's choice A. Moving to 19. 19 says we have a curve, has a slope. So we have the slope of a curve at 2x plus 3. All right. For each xy on the curve. Which of the following is the equation of the curve if it passes through the point 1, 2? So the curve passes through the point 1, 2, and we're given the slope. And what we're supposed to remember is that the slope is basically the derivative. So if I want to find out what the curve was, I need to integrate. I'm going to integrate 2x plus 3. Dx. Alright, so when I integrate that, add 1 to the exponent divided by the new exponent plus add the x if it's a constant plus c. So I'm going to be left with x squared plus 3x plus c. And when we take a look at the given point, because which of the following equations, it goes to the point 1 comma 2. So if I plug in 1, I need to get 2 out. So this is going to be my y. And so I'm going to get 2 when x is 1, so we can solve for c. So I'm going to get 2 equals 1 plus 3 plus c. 2 is equal to 4 plus c. Let's subtract our 4. We get c is equal to a -2. If c is equal to a -2, let's go back to my equation, which is this equation here. So y is going to equal x squared plus 3x, and then minus 2. And I see that here as choice D. Number 20. Number 20 says, and again, these are always the crazy ones, you know, which of the following above is true, and you get your I, double I, and your triple I, so you have to really know these questions. They get a function that's defined over 2 different domains. It says, let f be the function given above, which of the following statements is true about f. So I is the limit as x approaches 3 of f of x exists. So for this to be true, we need to know that as x approaches 3 of f of x needs to be equal to, and that's from the positive side, needs to be equal to as x approaches 3 from the smaller side of f of x. Alright, so let's go ahead and figure what this is. If x is going to be approaching 3 from the positive side, so let me kind of draw this here. Alright, so here's my 3. So I'm going to be approaching 3 this way. That means I'm greater than 3. If I'm greater than 3, I'm using this function. So I have 4x minus 7 equals. Now I'm approaching 3 from the smaller side, so I'm approaching 3 this way, which means I'm less than or equal to 3, so I'm going to use x plus 2. And once I realize what's happening here, there's no problem with just taking a 3 and plugging it in, so I'm going to do that. So I get 12 minus 7 is supposed to equal 3 plus 2, and we get 5 is equal to 5. Since that works out, the function or the limit as x approaches 3 of f of x exists, so that's good. So right away in a question like this, you want to go through your choices. Choice A is none, and we already know that I is correct, so we're going to cross that one out. B is 1 only. That could be the final answer. We don't know yet. C is 2 only, so I can get rid of that because I know 1 is true. D is 1 and 2, and E is 1, 2, and 3. So we are good so far with that. F is continuous. So now we're going to add a little piece to what we just happened here. We know the limit exists, and the limit actually is going to go to 5. So what's happening here, for this thing to be continuous, remember, for a number to be continuous, in this case at x equals 3, the limit as x approaches 3 of f of x needs to equal f of 3. So we know that this is 5. So does f of 3 equal 5? And if it does, we're good. Well, I come up here and now I'm letting x equal 3. If I'm letting x equals 3, that's in this domain, which means I use that function. If I plug 3 into that, I get 5 and we're good. Which means number 2 is also true. We are continuous. So that means I can get rid of B. So now my choices are going to be 1, 2, or 1, 2, and 3. So even if you had to guess at this point, you got a 50-50 chance. So that's how you want to attack one of these questions. Finally, 3, differentiable. That means when I take the derivative of f, I'm going to get the same number when I plug 3 in, or basically as you're approaching 3. So I should wind up getting the same thing here. So if that's true, then that means when I take the derivative of the first function, so when I take a look at f prime, the derivative of that's going to be 1. When I take the derivative of f prime of this function, it's 4. So if I start playing around with this as we approach 3, again looking at the derivative, differentiable, looking at the derivative through the eyes of a limit, I don't get the same answers. So it's not differentiable at x equals 3. Therefore, choice D is going to be the answer. We'll go through one more real quick here, and this one is given a graph. The second derivative of the function f is given above. The graph of f double prime is shown above. Which of the following values of x does the graph of f have an inflection point? Okay, you have to remember that we're looking for the graph of f and we're looking for the inflection point. So by definition, we're looking for where f double prime of x is equal to 0. All right? So that's the first piece. Those are possible inflection points. Well, where does that happen? That's going to happen here at B, and it's also going to happen at O, or the origin, and it's going to happen at A. So those are the 3 places where the graph could have an inflection point. Now, by definition, an inflection point is going to be a point where the sign changes around the 0. So here you can see the second derivative is positive, and then it continues to stay positive, so you don't see a sign change. So this can't be an inflection point. Here, it's positive and negative, so this is an inflection point. Here it's negative and positive, so here is an inflection point. So this is going to have inflection points at O and at A only, and that's going to be choice A.